Okay, so I'm just back here at where my lab setup is, so I'm just going to introduce the materials that we're going to be using today. So I'm going to use my phone to film the car as it moves down the ramp. That's because my phone has one of those slow motion captures, so I'm able to kind of slow down time and make sure that I get my displacement values correctly. So we're going to be using two different types of cars. So this black car here is the black Chrysler. This one here is the blue buggy cart. This one here is the Mitsubishi Eclipse. It might have been Nissan Eclipse. I have to double check that, but this is the Eclipse vehicle. This is the blue physics cart. So let's move over here and start doing our lab. So one of my questions here is that in my labs is that I'm asking you like what are some two sources of error, and the two sources of error I'm just gonna help you out with this one. Number one is gonna be air resistance, right? One thing you know is that whenever things in motion, you feel sometimes air get in the way. So that's one of the things that's an experimental error that we can't control, right? So that's just something caused by nature. Another source of error that's caused by nature is what we call friction. So if you look up on the board here, this is the formula you're going to be working with if you do decide to take Physics 20. So next year, you're going to calculate what we call the frictional force. And that is dependent on something called the normal force and the coefficient of friction. So the coefficient of friction essentially just means the rougher the terrain, the more traction you get. But however, with that traction, it takes more energy for you to move, right? So if you think on a really like muddy surface, you feel like you're like really sticking to the ground, right? So you're not slipping and sliding. That's one of the things that has like high tractions, right? Versus if you're skating on ice, it doesn't have a lot of friction, so that's why you're able to move faster than when you don't have skates on. So on this plane here, it's pretty smooth, so that's really great. That will really eliminate some of the frictional losses, but there will always be frictional losses. In the real world, it's almost impossible to kind of create a surface without friction. So friction will always be one of those experimental errors whenever we talk about motion. And air resistance as well, because like, there's those air in there that stops the motion of a car, right? So if you're driving either by yourself or with a friend or your parents, you know is that as you drive, like there's like some bursts of air coming to hit against you, right? So that's the air resistance I was talking about. Okay, so let's get the experiment started now. So we'll start out with the black Chrysler. So once again, just to keep the experiment consistent, I'm gonna keep all of my cars at the back wheel hitting the back line. So we're trying to eliminate possible reading inaccuracies. And yeah, so we're just gonna roll it down 2 or 3 times, and I'm gonna slow down my film so I get data for you, right? So I'm just gonna capture the first couple, and then I'll just save the rest of the video like to watch for myself and calculate the distance that way. But I'm always gonna calculate the distance around like the middle of the car, so like approximately right here. So I'll just film the first few, and then the rest I'll just calculate the distance on my own. So here it is. Let me just zoom out for a second. Right, so you can, yeah, so just like that, okay. Hold on, I'm just gonna stand up like that. There you go, there you go. There, so now I can see both the measurement as well as the as well as the car. 1, 2, 3. Oh, sorry. 1, 2, 3.